So welcome back, everybody. This is officially week 12 of our sessions. And I think it's time for us to refocus our attention a little bit to a discussion about files and directories, in general the file system, and what we can do programmatically with objects on the file system, and what kind of information we can read and write from files and so forth. So this is an interesting aspect, and this is also going to be, I believe, the focus of our final exam online. So this is yet another reason to begin to cover it now. But we still have a couple of more assignments, and they're also including graphical user interface components in those assignments. So we're going to be switching back to our conversation about graphical user interfaces. And so it's just our agenda is kind of packed. But today I think is the right time for us to begin talking about files and directories. So before we go to an actual presentation, I would like to just to give you a very quick overview of a file system. So let me just go maybe to a scratch pad here, and we can have this small discussion about files and file systems. So generally speaking, on the computer system, there are two types of devices, right? So we talk about the devices. We have two types of devices: character-based. Okay, so the examples of those is like a keyboard, mouse, and other types of input devices like that. Console window, right? Console window is a definitely character-based output device. But there's also a second type of devices, and they're called block devices. Block devices. Block devices are all kinds of disks, right? Disks, other types of permanent storage, right? Permanent storage. Those include like flash drives, then there's also solid state drives, SSDs. There are also traditional disks, CD-ROM, DVD type of disks. These are all block devices, and we're just generally speaking switching a little bit to talk about the block devices. So what's interesting about the block devices is that typically no one talks with them on a character-by-character basis, right? So no one is expecting to get a single character from a disk drive, right? So what happens is that those disk drives are basically subdivided into something that we call, essentially you have your disk, right? You have your disk. This is a big disk, maybe like, 4 terabytes in size, pretty big disk, right? And so it can be subdivided into volumes like this, right? So typically at the beginning of the disk, there's some kind of a partition table that describes where information begins in each partition. Each partition may have a volume, and this volume typically hosts something we refer to as a file system, right? So there's a file system. The modern file systems are typically hierarchical file systems. So you have a set of directories, like, for instance, you have like something like a root directory, right? And there is a subdirectory 1, then maybe a subdirectory 2, like that. Right? There could be subdirectories. These subdirectories can also have other subdirectories. So this is really just a hierarchical type of system. And a subdirectory can also contain files, right? Files and so forth. So typically you can have multiple files just like that. right? So this is this structure, this logical arrangement of root directories, subdirectories, and files all together are all packed into this file system which hosts it. So in software, normally, unless you're doing some kind of low-level analysis of your file system or the entire disk, or maybe trying to repair it, or maybe trying to recover damaged, recover information from a damaged disk, unless that's the case, you would normally like to go and work with block devices at the operating system level, right? So let's go to another version of this presentation and just say that supposedly what happens is that you have this disk drive, right? You have this disk drive. This disk drive normally has an operating system driver installed, right? So you probably want to have some kind of a driver. So this is as much as we can say about this, the operating system involvement. Most likely also, you have some sort of operating system support for files, such as, for instance, so this drive will ultimately contain files, not only files, but also subfolders or subdirectories. So, but multiple files can be accessed on a specific disk, supposedly. But there's also some kind of memory buffer, right? Which temporarily stores information as you read and write information from this disk. Now we call them block devices, right? Block devices. For the reason that typically this is some kind of a permanent storage, right? Storage devices. Permanent storage devices compared to memory are slow, right? So they are slow. And that's why you don't want to, with every operation, with every attempt to read or write information, you don't want to extract individual bytes. You would like to essentially populate this memory buffer with blocks of information, right? With blocks of information, and typically you want to read entire 512 or maybe 1 kilobyte or 2 kilobyte size blocks to populate, to exchange information at that level with your file system. Okay, and so this is the reason why they're called block devices, because normally information exchange with them at the level of the operating system driver, the actual disk controller, the actual disk is done by these big chunks of information. And that's why when we write our application, right, so this is our application program right here. This is our own application program. So you typically have two choices to work with files. One choice would be to somehow find a way to communicate directly with the operating system driver. This case, there is no any kind of memory buffering that takes place. You just want to communicate directly with the operating system driver, perhaps in order to do some low-level maintenance work on disks or files or file system. For instance, try to change attributes of a file or try to rename the file. Do something really kind of low-level operation that, or even read and write information from a file, but without any kind of buffering. So in that case, there is something we would name actually unbuffered, let me just actually write this nicely, unbuffered I/O, input-output. And the second way of work is to actually use this memory buffer to exchange the information with the operating system driver, and this would be obviously buffered, right? Buffered I/O. Okay, so buffered and unbuffered are two principal differences of working with the file system. So we're going to largely focus on the buffered I/O. Okay, so buffered I/O is going to be a set of tools that we're going to explore. Unbuffered I/O typically used by applications such as databases. For instance, database presumes concurrent access by multiple processes, by multiple users, and therefore it needs to keep the information current as much as possible. Whereas the buffered I/O presumes that you ask the operating system to take care of this information that you want to store on disk, but you really don't care when the operating system will decide to make that actual update, right? So it's very different compared to unbuffered I/O, and unbuffered I/O typically requires more skills, more understanding of the actual underlying hardware and the operating system and memory and many other aspects. So typically this is a low-level type of programming. There are usually restrictions on how much information you can read and write at the time, and without you actually knowing what that specific parameter or set of parameters is, you may actually create some damage, right? So we're largely going to focus on buffered I/O and not worry about any kind of low-level details of this kind. So we will continue mentioning the difference between buffered and unbuffered I/O, but most of the time, when you write your application programs, you're going to be focusing on buffered I/O. The weak part of the buffered I/O is that unless, again, it's supported directly by the operating system, it's hard to keep your input-output operations transactional. In other words, if there is a file, right, if we have a file someplace on the file system, so there's this disk, right? There's this disk right here, and there's a file, right? And there's this operating system, and we're trying to use the operating system interface, and there's program 1 and program 2 that both are trying to use the same file. So this is like file, data file. How about that? Data file, right? So both programs are trying to talk to the operating system, and they're both trying to write information into this file. So the operating system somehow has to serialize and prioritize these requests and somehow being able to update this information. So it's possible with buffered I/O, which is supported by the operating system. Normally, this is the default type of input-output. What happens when you have this buffered I/O that goes to some staging stages of storing temporarily information before it gets written, when the operating system decides when to execute that type of exchange with the actual hardware. It's possible that if program 1 writes this information here at the beginning of the file, all of a sudden information written by program 2 could corrupt this data and override it, right? So it's not very easy proposition. However, you can ask the operating system to, instead of just writing arbitrarily in any location of the file, which would normally be done by a smart type of software like such as database system. Instead, you could be asking the operating system to append. If you say, we just want to append the data, typically the operating system will make it transactional, and the information will be appended to the end of the file, and normally speaking, this will be safe. So there is a guarantee that by the operating system, when you run in append mode, the appending operations on your files will be multitasking and multi-user safe, so that everybody will be updating your files, and even if two programs are trying to do the same thing at the same time, the operation will be safe and no information will be lost. However, If you try to use like random access to your file, this again becomes a very serious concern. So we're going to focus on different aspects, and although in our small programs, most of the time we'll be just focusing on the functionality of a single user trying to work with a single file. Remember that the consideration for working with file systems and what's involved with them is actually larger than that. There is lots and lots of layers. There's also locking, right? Sometimes you want to ask the operating system to lock the file or lock a certain area of the file so that you exclusively can go in and update that data. And typically, this is what's done by the databases. So if you need that type of access, you should probably consider using a database as opposed to writing something sophisticated like that from scratch. So we'll have a chance to discuss this and different aspects of it. But primarily, we will be focusing on the work done on individual files by a single user, and most of the time, we're just assuming that this is a single user with a single file, and it's all perfectly safe. However, in real life, this may not be the case if you're working in the server environment with multiple factors involved, right? So let's get started, and we will open and try to execute as many samples as possible as we make our progress through this discussion.